The first thing you want to do on these tanks, now I have mine already assembled, but what you want to do before you ever assemble the regulators onto the tanks, you want to stand to the side, and this regulator not being attached, and you want to crack the valve. Let that oxygen blow out and clear any debris that's contained in this fitting right here. You also want to do the same on the acetylene. Give it a good crack, a good blow. Make sure you stand aside. That way no debris or anything comes flying out at your face, in your eyes, etc. You also want to inspect the valves on these to make sure there's no oil or grease, because oxygen and oil and grease do not mix. It creates an explosion hazard, and you want to make sure that everything is clear of oil and grease. The second thing you want to do a visual inspection on your hoses, and also check and make sure that your hoses are located in a safe area where when you're actually performing the operation, that none of the hot alloy falls on top of the hoses and punctures the hoses while you're performing the work. You want to do a visual inspection of your environment, your immediate environment, to ensure that there's nothing flammable and that you're not going to cause anything to get caught on fire. And you want to make sure that you have a fire extinguisher of the right class when you're doing this. And I do have one located within about 10 feet of me here. Anyways, back to the measures to check and make sure that your rig is safe for operation. We blowed any dust and debris out of the tanks, and now we want to affix our regulator. Now, if you notice on our regulator, we have devices on here that are referred to as a check valve combination flash arrestor. And this is to prevent any of the fire or any of the fire coming back to our tanks and possibly causing an explosion or a fire. But all these are possible leak points where the regulator attaches to the oxygen cylinder, and also where the regulator attaches to the acetylene cylinder. You want to have a process to be able to check and make sure that none of these are leaking. Now, one thing else I want to go over also is on the acetylene regulator, you can't see it, but there's indentions in the nut right here, and there's also indentions here on these fittings as well, which lets you know that these are not right-hand threads. They're actually opposite of what you're used to. They're left-hand threads. So when you're loosening these and tightening these, always remember that on your fuel gas, if it has these indentions on there, which it should, that you're always going to be opposite thread. And of course the oxygen is your standard right-hand thread, okay? So our next check is, before you ever open the bottle and when you affix these regulators, you want to make sure that these adjusting screws, which adjust your operating pressure, the pressure that's leaving the regulator and going into the hoses to your torch assembly, you want to make sure these screws are backed out. That turns off all flow of oxygen and gas. And we want to do it that way anyways, because we want to check and make sure that this connection right here and right here doesn't have any leaks, so we can prevent any fire or any gas bleeding off into this space. So what we want to do is, with this backed out, we want to stand to the side, because when this oxygen or gas suddenly releases into this regulator, it is compressed in this bottle, and when it comes out, it's allowed to expand, and then it gets sent back into this regulator where it's immediately compressed again. When it's immediately compressed again, it's been known to send this adjusting screw flying in a direction towards you if you're standing in the way of it. So you always want to stand off to the side when you do this. So we're going to come over here and we're going to crack our valve, and then we're just going to close it again. And we're going to look at what pressure we have on our gauge, and we're going to watch it for a period of time to ensure that nothing's leaking right here. Because our valve is opened, nothing's flowing out the hoses, so this is the only fitting that could be leaking right now. So we're going to check that for an amount of time, make sure that the needle doesn't drop until we're satisfied that there's no leaks. Okay? Then we're going to close the bottle again. So we've checked this fitting here. We also want to do the same thing on the acetylene connection as well. Now I'm not going to do that because I've already done it prior to the filming, but we done it right here, and you're going to do the exact same thing on the fuel gas. Now the next thing we want to do is we want to check and ensure that these connections are good as well, all the way up to the torch. If you notice the same thing, you've got the indentation on the fuel gas, which tells you this is reverse threads, and the acetylene does, and the oxygen does not. And if you notice, these hoses are color coded, okay? Green is always going to be your oxygen, and red is always going to be your fuel gas. So we want to be able to check and ensure that those have no leaks, as well as the hose itself. Even though we do a thorough inspection of the hoses, it doesn't mean that we can pinpoint every single leak. There might be a minute pinhole or a cut or an abrasion that we have not been able to see yet. So once again, we're going to make sure this is backed out. We're going to crack the oxygen valve open, and we're going to make sure that these valves are closed on the torch, okay? We're going to make sure that these are closed, and then we're going to turn the adjusting screw in until I get, I like to do 15 psi. Now, I've just pressurized these hoses. Now I'll close the tank, leaving the valve where it's located with the adjusting screw in, and I've got, it looks like actually about 17 pounds per square inch on the hoses, all the way up into the torch connection, and this is the end of the hoses. So I've got pressure up to this point. I'm going to close the bottle again, and I'm going to once again watch my gauges to ensure that none of the pressures are falling. If the pressures are falling, that means I have a leak somewhere because I'm not burning any fuel gas or oxygen. We've got the valve closed. We're going to do a standing leak check on all these components, and we're going to watch the needles and make sure that they don't drop as well. Once again, we're not burning any fuel gas. We're not using any oxygen. So if anything is dropping, it's simply going to be because of a leak. And once you're sufficiently done a leak check on your heating system, then we can go ahead and step into the actual brazing operation. So I'm going to take my torches, and I want to set my pressures on my oxygen cylinder and my acetylene cylinder. Now, once again, I've already checked the acetylene cylinder, so you have to do the same process that you performed on the oxygen cylinder and its hosing and device and components. You also have to do that to the acetylene tank as well and its particular hose and connection. So now we've safely checked and made sure that everything is safe for operation, safe to begin the brazing process. So what we're going to do next is, we've got this closed. I'm going to back the adjusting screw back out to 0. I'm going to purge off all my gases. So I start from scratch. And now I'm going to open my valve on my oxygen, cracking it while I stand to the side, and I'm going to open it all the way. Oxygen valves, oxygen cylinders have a special type valve, and you're supposed to open these all the way. Now I'm going to crack my oxygen valve on my torch assembly. I'm going to crack it open, and I'm going to adjust this in until I get 5 to 7 psi, just depending on what size pipe that you're going to be brazing. Obviously, the larger size pipe, the more heat it may require. We're using a number 5 tip, which is actually a little large for 1-inch copper tubing, but it's the one that's already attached here, and we can do that with this tip just fine. Know that you don't have to have every single tip to perform an operation, but if you have too small of a tip, you'll never be able to get the tubing and the coupling hot enough and keep the whole surface hot enough to get good penetration and have your filler metal go where it needs to go. So we've successfully set our oxygen pressure, and now we're going to do the same thing with our acetylene by standing to the side, cracking the valve open slowly, and then open it a half a turn and no more than a turn and a half. Okay? We're going to crack the fuel gas, which we're using acetylene valve here, and we're going to run the adjustment screw in until you get the desired fuel gas pressure that you want. I'm using 5 to 7 as well on it. Now we have our gas pressures and our oxygen pressure where we need to perform the brazing operation. So now we're ready to perform the brazing operation.